Good afternoon, everyone. Welcome back. Thank you for joining us. We are glad that you're with us. My name is Steve,
And I'm Scott.
and together we are Backyard Musings, the Science and Technology channel.
Yep, and we're talking again this afternoon like we did this morning. We're talking about space and involving the James Webb Space Telescope. And that picture you see there is pretty cool. So we're going to talk about it.
Really cool. Webb's breathtaking view of the Helix Nebula shows a dying star's final breath becoming the seeds of future worlds. First identified in the early 1800s, the Helix Nebula is one of the most recognizable planetary nebulas in the night sky, known for its dramatic ring-like appearance, almost like an eye. I was talking with Scott about this.
Yeah.
Because it is one of the closest planetary nebulas to Earth, astronomers have long used both ground-based and space-based telescopes to study it as a detailed example of how stars end their lives. Would you like to know more?
This is fascinating, right? I mean, how one star ends and then
Sets the seeds for other.
yeah, it's like a Joshua tree seed pocket. They burst open, and yeah, it's pretty cool. Those observations have now reached a new level with the James Webb Space Telescope, which has delivered the clearest infrared view yet of this well-known object. Webb's powerful instruments allow scientists to zoom in on the Helix Nebula and examine what could one day happen to our own sun and planetary system, hopefully long after we're all gone, right?
Yep.
The telescope's high-resolution data brings the structure of gas streaming away from the dying star into sharp focus. These observations show how stars return their material to space, providing the ingredients that later form new stars and planets. Again, this is just more evidence that somebody created all this and continues to create it, right?
Yes, sir. Images captured by Webb's NIRCam, NIRCam infrared near-infrared camera, reveal striking pillar-shaped features around the inner edge of an expanding shell of glass. These structures resemble comets with long tails pointing away from the central star. They form where intense winds of hot gas collide with cooler layers of dust and gas that were released earlier in the star's life, carving the nebula into its complex and textured shape. Okay, let me get a second.
Okay.
There we go.
Okay, so
that's
this
cool, isn't it?
Yeah, that should give you a broader or a narrower perspective of what we're looking at there. So, this image of the Helix Nebula from the visible and infrared telescope for astronomy, which is the vision on the left there, shows the full view of the planetary with a box highlighting the smaller field of view from the James Webb Space Telescope, NIRCam or NIRCam on the right, which I think the one on the right's the one we were looking at earlier, right?
Yeah, where the box is. Yep.
Yeah.
Over nearly 2 centuries, the Helix Nebula has been observed by many different telescopes. Webb's near-infrared perspective highlights dense knots of gas and dust far more clearly than the Hubble Space Telescope's softer and more ethereal view. This new view also makes it easier to see the sharp transition from extremely hot gas near the center to much cooler material farther out as the nebula continues to expand from the central white dwarf. I guess there's a white dwarf in there in the center.
Is that not the one that's boxed out there? Or oh no, that's just showing us pictures.
The center is
just highlighting that picture on the right.
Yeah.
Gotcha. Okay. At the core of the Helix Nebula lies a white dwarf, the exposed remnant of the original star. Although it sits just outside the frame of Webb's image, powerful radiation from this stellar core illuminates the surrounding gas, creating layers with very different properties. Closest to the white dwarf is hot, ionized gas, followed by cooler regions rich in molecular hydrogen. Farther out are sheltered pockets within the where more complex molecules can begin to form. These regions are important because they contain the raw materials that may eventually rise give rise to new planets elsewhere in the galaxy. So not a guarantee.
I don't understand. How do they know that it's rich in molecular hydrogen and then it's hot ionized? How do they know that?
I don't know. Maybe the color. Maybe they can see something that they haven't revealed to us yet, us minions. But
I don't know.
But yeah. But in that it says that it may eventually give rise to new planets. So they're not all guaranteed, right? It's
probably because we haven't witnessed new planets forming from something like this. It takes a long time.
Yeah, millions and billions of years. Yeah.
Yep. Okay, this image of the Helix Nebula captured by the NIRCam instrument on the James Webb Space Telescope includes compass arrows, scale bar, and color key for reference. To create this image, near-infrared wavelengths of light have been translated into visible light colors. So it's important that this was infrared, and then they put it into color that we can see. The color key at the bottom shows which NIRCam filters were used and which visible light color was assigned to that filter.
It's interesting that the compass at the bottom there, the bottom left-hand corner, our left-hand corner, it's opposite. So east is normally on the right side. That's on the left side.
I guess it's how the telescope is oriented,
Yeah, so
relative to us,
Yeah, it's opposite. Interesting. Yeah. The north and east compass arrows show the orientation of the image on the sky. Note that the relationship between the north and east on the sky is flipped. Oh, see, there we go. Is flipped relative to direction arrows on a map of the ground, as seen from above. In Webb's image, color is used to show differences in temperature and chemistry. Blue tones highlight the hottest gas, energized by strong ultraviolet radiation. Yellow areas mark cooler zones where hydrogen atoms combine into molecules. Red shades appear at the outer edges, tracing the coldest material where gas thins out and dust can form. Together, these colors illustrate how the final outflow from a dying star becomes the building blocks for future worlds, deepening scientists' understanding of how planets originate. Okay.
The Helix Nebula is located about 650 light years from Earth in the constellation Aquarius. Its closeness and eye-catching structure, no pun intended, have made it a favorite target for both amateur sky watchers and professional astronomers.
Okay. Got to have a pretty good telescope, I would imagine, to be able to see those things, right?
But if it's a favorite of people, I'm sure amateurs can pick it up. They know where to look in Aquarius.
Yeah. Well, just like I was telling you, I forget if I was telling you on air or off, but those telescopes that they were using at that STEM exhibit the other night, they were pretty cool telescopes. And the guy goes, yeah, these are relatively inexpensive. They were about $300. And they were pretty good size. I mean, they were 18, probably between 14 and 18 inches in diameter and about maybe 4 foot long.
That's big.
Yeah.
That's big.
And so and they had NASA's name on the side. That's what the cool part was. They you'd probably have to pay more for that. So, but yeah, I was pretty impressed with the view. So anyway, good story.
All right, folks, we hope you enjoy your Sabbath. We'll catch you on Monday.
Yep. Have a good rest of your weekend, and we will talk to you on Monday morning. Take care.